Hello. So, day 3 here. I went up this morning. I was slept a bit too long, so I was up at around 8 and started day 3 of Advent of Code. And I was really tired, and I cannot do that like I did today. Just go up, and I felt a bit stressed that I needed to get started with the Advent of Code because I had things to do at around 10:30. So I just wanted to do this first and then do my morning business, so to speak. But I think I have to do my morning business before I do Advent of Code because my brain wasn't where it should be for solving programming puzzles. So I got stuck on the program, and I actually sat there for 2 hours. I recorded it, but I just immediately deleted the recording. But trust me, I spent 2 hours and I almost solved it. I was so close on the second one, but it was so weird, the bash script I had came up with. I'm not sure what I did now when I look at this final solution that I got, because then I did my stuff and I could get back to the problem at around 11:30. And I just fixed it in 15 minutes and cleaned up the code and everything. It was, I just needed my coffee and stuff, But this is the solution for day 3 there. So instead in this video I will just talk shortly about that problem. Let's see, I guess it's here. Yeah, it would. I'm not sure if it is difficult or not actually. But it is one of these path tracing problems, and they can be somewhat tricky. I will show you where I what went wrong in my solution. So you are Santa here or whatever who is supposed to travel from here, this position, to this position under this grid here. And all of these, they are trees. So you need to calculate where there are trees. And when he's traveling down this path, he do so in a special pattern. The first exercise was that he travels in this pattern, right 3, down 1, meaning you start here and then you go right 3, 1, 2, 3, then down 1. And that repeats here, as you can see, 1, 2, 3, down 1. And here where there is an X, that means it's a tree at that position. We can also see, because this made it, this was one thing that messed with my brain a bit, is because you can see it's a repeating pattern. It's actually just this pattern is repeating over and over again here in these example files. The input file looks a bit different, but the same pattern repeats over and over again. And the input file is actually much larger, of course. It's much longer. So imagine if you're going from here to the bottom, this will become very long. The lines will actually be like, would be almost 1,000 columns wide. And that becomes a really large grid array thing if you want to store it like that in Bash. Very slow. I kind of first I thought I could do it like that, just brute force starting like that, but it got too slow to test the script and stuff when I did that. So I also knew that there must be a way to just calculate the position we are at, and when you reach this point, since it repeats itself, we can just know that if we go 3 steps from here, that should be 1, 2, 3 like this, if that would be the case, if you see what I mean. So this, somehow I messed this up completely before I solved it here. Another thing that was weird is that you start here, so the first line is actually completely irrelevant for calculating how many trees. You always know that the first position, this top left one, doesn't have a tree. So you don't have to think about that at all, meaning you can skip the first line completely. You kind of have to do that. So the first position you check is actually Y4, because it's 1, 2, 3, 4, right? And down 1 in a 0 indexed array. Yeah, then I guess this is 1, 3, which makes sense now when I look at it here. 1, 3. This was also something that broke in my uncaffeinated brain. I started making like a separate value holding the character I needed to test. So it's like x will be 4 because it's the fourth x position here, the fourth coordinate. But the character is actually 3 since it's a 0 indexed string and stuff like that. I did all of these weird stuff. I made a really complicated way of ignoring this first line, meaning I had to add some extra tests and I incremented the line sometimes when it in reality only needed to be done once, you know. So what I ended up with here is to make a slice of the array. First read this whole input file into an array called map. Also have to know the length of each line, and this is something I did this immediately when I started with the puzzle. I was kind of close actually from the start, but I did these small things that made it like unsolvable for me. Also because the code got so messy because of it. But I need to calculate the length of the grid. And I know that every line have the same length, so just grabbing the first line in the array, the 0 index, and then doing this give me the length of the first line, meaning the length of the grid, because I need to know that to know when to repeat, you know. And then, where is it? Maybe I don't do it here even. Yeah, whatever. But then we make a slice when we loop through the whole, because we only have to loop this once, but skip the first line. And you can do that by just making a slice of the array, just like you do a substring, but here instead it starts from the second index, meaning index 1 of the array, skipping the first one, and then every other index. So that starts from the first. But then part 2 also made it even more complicated, because then you got more patterns. This is the 3-1 pattern, is this we see here, 3 right, 1 down. But in the second solution you were supposed to calculate 4 more move patterns, so to speak, and I got them written down there, like 1-1, 3-1, 5-1, 7-1. And then this one that becomes really problematic. I thought it would be easy to just add it like a loop here, and all of these were correct like immediately for me. But this one became completely different, because here it is like 1 right but 2 down instead. And what that really means is that you need to skip every other line. And I don't know, something broke for me with this, how to calculate if I should skip a line or not. But what I do is just taking here y%2, that will be meaning y is the line number, and if the line number is even, then y%2 down, and down is the pattern there, meaning 2. So y% down, that will give us the remainder of y divided by down, meaning if you divide 3 with 2, you will have a remainder of remainder of 1. But if you divide it by 2 or 4 or 6, you will get 0, and then this test will actually fail here. And these are the lines we are interested in, 2, 4 and so on. But if it passes, then we still increment the line and then continue to skip that line. This was something that I made a really complicated, weird solution for this first. This is the part where I extend the pattern, or have it repeat itself in the x-axis, you know, when a line reaches this position, to shift the rest of the stuff, or how to say it. Also found that this simple solution for that. This is line width, this is the current x position. So that worked. And here x divided by the width. So that can become 0, and then 0 by the line width is nothing. But if you can, since bash rounds everything down, you know, if you can do this and multiply what you get here with the line width and subtract that from whatever x value you have, so you can have an x value that is like 1000, this would still work. And then we can just print this character on the x position, just one character. And when this was done, it was really fast and quick here, but it took really long time. It took over 2 hours for me to reach this point. So I did the solution, but I just it deleted the video because I was not satisfied with it. And of course, the calculation was to multiply the number of trees in each pattern. So here I set a value that's called sum to 1, meaning that I can do sum times equal, and then the number of trees I have found in this one here. If I don't set sum to 1 here and have it unset, then it will be 0 from the start, and that means it will always multiply 0 with the number of trees, resulting in 0, and then do it, so sum will always get 0. So you need to set it to 1 for this to work, because 1 times something is that something. And the next it's that something because times something else, and that, yeah, it works. So this actually works. This is a good solution in my opinion, and it also makes good use of the capabilities available in Bash. I also had like a double loop here where I first did map file and then I also did a while read. Not sure what I was thinking. So this is what I came up with. I will just add this video to the playlist for to keep track. It felt bad that if I would have missed 2 days in a row with videos here, but I actually solved the puzzle. I did it without cheating in any way, because if I was cheating, then I would probably not say that I did that it took me 2 hours, because that is kind of that is a bit too long for these puzzles. I don't like that they should take more than an hour. And I'm sure I would have done this in 30 minutes if I had gotten my time in the morning, like having a cup of coffee and things like that. Like 15, 30 minutes. But I really just went straight from bed into doing this, and that didn't work at all. So I blame that, and I actually think that is that is what happened, because I also felt it constantly. It's like I just, the brain doesn't work as it used to. So that's a recommendation for anyone doing Advent of Code. If you're doing it early in the morning like I do, try to get up at least 20 minutes before and have your coffee or whatever you need in the morning, you know. Going punch drunk out of bed into this was complicated, but still it's a good exercise, a good puzzle. This, I think the puzzle was really good actually. It's I like these things where it is a bit something graphical in a way, but I should have solved it faster. But I can also see on the leaderboard, you can kind of see the difficulty of the puzzles a bit. If we look at the first day, well, the first day was actually pretty slow. Very slow actually to solve both puzzles on the first day, because the second part of the first day was really weird. This might be to the server overload, but yeah, I wonder, because second day the puzzle took 1 minute and 47 seconds, and this was not an outlier. You can see top 100, the 432, and then if we look at day 3 here, we'll see it's a higher time needed. Like 233 is seems to be like the top 10 here, and top 100, yeah, well, it's 5 minutes, so almost the same span, but it seems that this was a little bit more difficult. But I guess if you just go into it with the correct idea on how to solve it immediately. I also had like the weird, I'm not sure if because often I think like I just try to solve it, whatever. I am a little bit like that. I don't like to analyze things too much. I think it's better to just get going and then work from there. I don't like just sitting still and analyzing what will be the best method here, meditating on it a bit. That's not really my style. But I guess I should try that a little bit more. Another thing that really helped that I should highlight here is that you can do this. For almost all of these puzzles, there is an example. For example, this thing here is the example output that they use in the examples. So, and then we can see that when they apply this write 3 down 1 to this example, they are the same here. They just added symbols in this one to actually show how the pattern works. But if you use this example with the 3-1 pattern, you should get 7, should be the answer. And that should be the same for everyone here, you know. And you also get examples for the part 2 here, where you got 5 different patterns. On the example file, that should result in 236, and that helped a lot when I started using the example instead and parsing that. Then I could take one pattern at a time here for part 2, because I noticed that all of these were kind of correct except the last one. And then I could just focus on that and stuff. It's much easier. That would be really difficult to do when you don't know the answer for each pattern. Because here we see the pattern for each of the slopes, as they call it. This should result in 2, this in 7, this in 3, this in 4, and this in 2. And the example, as you can see, is much smaller than the actual input we got. We could actually run the example with just this part. Don't think I did that, but so I created another file. I got the input file, but I also got the example file. I guess that should work with this, and that's much faster also for you to parse it on your computer. And then I can just change here from input to example, run this, and there we get 336, which is the correct answer. So when you know that, then you kind of know that your solution works as well, and that also makes it easier to track. I could hand track these things if I needed to and stuff like that. So that's my little log here for Advent of Code day 3. I hope I will not have such a bad day again, but who knows? Who knows? It wasn't really because it was too difficult. I was really not in shape, so to speak, when I did this, and that is something that I can definitely adjust easy. So I will really try to do that. I hope everyone else had an easier time here with day 3, because it's too long, you know. 2 hours, that's too long to spend on something for 25 days like that. If I knew it would always take 2 hours, I wouldn't do this. But it's fine for this, and I actually had the time. I didn't have anything till 10:30 this morning, so it wasn't a problem. But if I knew it would always be 2 hours, that would be too much. I will try to aim for 30 minutes for both of the stars. But I also feel I learned so much just by these 3 days and these problems. This is so good to do this. And also to record it. It really helps me to get better at improvising and talking and stuff like that. This is good stuff. So have a great day, everybody. Bye.